those joining us from different parts of the world, a very good morning and a good day. On behalf of Director CLRI, I welcome you all to the International Webinar on Leather Sustainability, hosted in honor of Dr. J. Raghav Rao, Chief Scientist, CSIR CLRI. May I now request Dr. K.J. Sriram, Director CSIR CLRI, to welcome this gathering.
Good morning, good afternoon, and good evening to all of you from all the parts of the world. All the colleagues of the leather sector, members of the Executive Committee of the International Union of Leather Technologists and Chemist Societies, the thought leaders of the leather industry, my mentors of leather research, the colleagues from the alumnus body, representatives of the leather industry, and the students who have joined in here. This webinar was organized today as one of my colleagues, Dr. J. Raghav Rao, who is the Chief Scientist of this institute, is superannuating on 31st this month. Dr. Raghav Rao has made seminal contributions in the area of leather research. His contributions has been taken to various parts of the world, and recent times, one of his contributions on the waterless chrome tanning has been adopted in over 100 tanneries across the globe. So we thought that it would be ideal that we take this opportunity to honor him through a seminar on sustainability. The sustainability of the leather sector has become a key point, especially for the Indian leather sector, and it is slowly but steadily becoming a matter of trade as well. The industry at sometimes is confused. In certain areas, it has been suggested that the sustainability should link all the way to carbon neutrality and so on. And there are industries which are being targeting the leather sector as highly carbon negative as well. So with all these things, the leather industry has been requesting the Central Leather Research Institute to enable them to present their sustainability story. We thought that it would be ideal that we hear from the experts of across the globe so that India could take the role which every other part of the world is taking. And in this, the sustainability metrics or whatever is employed is uniform across the world. So this is the premises under which we decided that we will have this seminar today. I am extremely thankful that Professor Covington would lead this series of talks today. My association with Professor Covington dates back to my PhD thesis evaluation by him. And we all have been looking at you, sir, as a guiding factor. In fact, the most motivating factor for all the leather students of the Anna University Department of Leather Technology as well. We also have with us Wolfram Schulz, the chairman of the IUE, and he has been looking at best available technologies and so on and so forth for the leather sector. And we look forward to your lecture today as well. We also have Mr. Kim Sena from the JBS group, who has been doing some amount of tremendous work in Brazil on how to get one of those industries there on the path of sustainability or carbon neutrality even. Finally, but not the least, we have one of our best colleagues in Africa, Mr. Wondu Legacy. During his tenure as the Director General of the LEDI, India established its foothold in Africa, and we have been working with them since then in establishing Ethiopia in the research map of leather. Thank you, Mr. Wondu, for joining in on this day as well. I would finally welcome each and every one of you. I'm thankful for Dr. Ramasamy also has joined in now. I'm extremely thankful to every one of you who has joined in here today. And I'm very sure the industry, the students, and everyone would benefit from these lectures that is happening today. Thank you very much. And I would request Nishat to take it forward. Thank you.
Thank you, sir. As our director was mentioning, we start this international webinar with an illustrious personality in the leather world, Professor A.D. Covington. Dr. A.D. Covington is an emeritus professor of leather science at the University of Northampton, UK. He has had an illustrious 40-year career in chemistry and the leather industry, which started with a graduateship of the Royal Institute of Chemistry at Tennessee Polytechnic. He continued his chemistry experience with doctoral studies in physical organic chemistry at Stirling University, followed by postdoctoral research in physical chemistry at the University of Newcastle upon Tyne. Professor Covington then joined the British Leather Manufacturers Association, later to become BLC, the Leather Technology Centre of Northampton, UK, where he spent 18 years engaged in research and development, industrial consultancy, and problem solving in the UK and overseas. From 95 to 97, he was the president of IUL-TCS, and since 95, he has been with the British School of Leather Technology of the University of Northampton. Professor Covington has 21 doctoral completions and 230 technical publications to his name. He's now going to talk on sustainability, a leather science perspective. Over to you, sir.
Okay. Where's my presentation gone?
You have to minimize your screen and then you will see your presentations. Yes.
There we are.
Right. Screen share. Slideshow mode.
Oh. Now I need to get to my
Slideshow mode.
There we are.
All set.
Thank you. As you can see, I'm not very technical. Thank you for those kind words, Dr. Sriram. Personal greetings to Sami. I haven't got your picture up, but no doubt I'll see you a little later. I want to talk about a leather science perspective of sustainability. My colleagues who are going to speak later have their views, because there are several views the way that you can look at sustainability and how you can adopt sustainability. I want us to look at leather science perspective, if I can get this to work. There we are. As I see it, there are three scientific contributions to sustainability. That is the environmental aspect of manufacture, the impact of manufacture, the economics of the market, and the environmental impact after disposal of articles. So from my point of view, that means that we need to understand the principles that are behind the processes, that control the processes, that control the optimization and effectiveness of the chemistry. We need to be thinking about those principles in order to improve the properties and performance, to maintain the position of leather in the market, because it does face some competition. And of course, we need to look at what happens to leather at the end of its life. So, as I see it, there are 5 perspectives that need to be addressed, not necessarily in this order of priority. We need to review the mechanisms of individual process steps. We need to look at the delivery of reagents. That is, we need to get materials, chemicals attached to collagen in order to modify the properties. And we somehow have to get those reagents attached. We can use the scientific principles that I'm going to talk about in order to predict what we need in order to get an outcome that we desire. There are several elements within the overall process that are contributing to the environmental impact. We need to close those loops, and we need to adopt an end-of-life strategy. And lastly, as you might expect, pretty close to my heart, is education in leather science, but we'll come back to that. Okay, what mechanisms do we need to consider? We need to unhair. I shall mention that again. Opening up, I'm not going to touch on. That's too big a subject for this presentation. Chromium tanning is going to be with us for the foreseeable future, so we'll touch on that. We need to create and use a general theory of tanning to look overall at the way in which we create that stability and those properties and performance of the material that we want to sell. We need to sell it to be sustainable. And we're going to look at reagent fixation, because that's at the heart of everything that we do in leather making. This is another mechanism, area control, which is a product of the interaction between moisture content and temperature. But again, I'm not going to touch on that today. Let's take a quick look at unhairing. These are the reactions that we've been familiar with for the best part of a century. However, who keeps squiggling on my screen? Anyway, the problem is that in recent years it's been established that sulfide iron doesn't exist in solution. So S2- doesn't exist, so that means the reaction scheme at the bottom can't be right. Now we know that we can actually make the reaction work in a technological sense, so we don't have to throw our hands up in horror yet, but from a leather science point of view, we need to rethink the mechanism and the kinetics, because that might have some impact in the way in which we view the reaction, in terms of getting a better result out of the chemistry. Let's look very quickly at the delivery of reagents. Oh, got two there. Okay, reduced water using higher concentrations. It's a low-tech approach fundamentally, and it's well understood, and we also know what the limitations are. Solvent systems, well, these have been around for many years. I'm thinking of chlorinated hydrocarbons, acetone, supercritical CO2, and the latest one is dimethyl ether. Now you can easily imagine all the shortcomings, the problems that exist with each of those. So that is why none of those have actually ever been successful in a commercial sense. There are pressure techniques, direct injection. Those of you with longer memories might remember the Krauser penetrator. The principle works, but the machine didn't. There are other pressure techniques, such as using nip rollers, which was an idea for a just-in-time approach, which would contribute to sustainability, except, well, it works, but if you want to make water-resistant leather, then you're wasting your time. Recently, plastic beads have been introduced into the industry. It actually works well. There are advantages, and it is being applied commercially on a full scale. So that may well have a future. The newest approach is ionic liquids or deep eutectic liquids, and these are certainly going to be the future in some form or other, although it's in its infancy applying this technology, but it's worth looking at this. Because the notion of ionic liquids, liquids from solids is so counterintuitive that it's worth seeing it in action. I think that's really cool. Okay, let's look at tanning mechanisms. I have proposed the link lock thinking, and it's certainly worth embracing that thinking, because that will allow you to make changes to the technology that other theories, other views of tanning will not allow. So classical cross-linking, forget it. It doesn't help, and actually it's a dead end. In terms of understanding reagent fixation, we need to adopt the stepwise view, because that allows you to make changes with predictable outcomes. We'll look a little more closely at that in a moment. We need to think about processing not as a series of independent steps, but as an accumulation of multiple combination steps. We've got to think of every species that we attach to the collagen as playing a part in that cumulative reaction. As well, it's not just the fixation of a reagent onto collagen, but it's the interactions between the reagents which also influence the properties and the performance. So, and I'm going to mention this more than once, at any point in the process, you need to think of the system, the three-component system, the reagent, the substrate, and the medium, because that will allow you to analyze what's going on and how to make changes. Let's consider the general fixation mechanism. We're dealing with a heterogeneous reaction. It's not simple solution kinetics. It's a solid substrate and a liquid medium. So we somehow have to get the reagent that we're interested in from solution into the substrate. So that's going to depend on the relative affinities that the reagent has for the medium compared to the substrate. This is an example of partitioning. And that's partitioning effect is driven by the electrostatic interaction between the reagent and the substrate. So it might be a charge-charge effect, hydrogen bonding effect, or even a hydrophobic bonding effect, such as you get at the beginning of veg tanning. And of course, the reaction may go on to be covalent depending on the chemistry. For example, chromium is well known, and also condensed polyphenols. So, in general, the fixation reaction is controlled by all the elements of the system. You might think, how much control do I have over the medium, because I process in water? Well, in fact, you don't process in water, you process in a solution. And the properties of the aqueous medium depend on whatever else is in there. And it can make it a little more hydrophilic or a little more hydrophobic, depending on those solutes. That's two. And the properties of the substrate, the leather that we're making, depends on the accumulation of reactions, charge and hydrophilic hydrophobic balance. And of course, if you recall, charge is a consequence of isoelectric point and pH, and the change, the accumulation of reagents on the collagen is going to modify the isoelectric point, and at any pH that will control the charge. Unfortunately, we don't know exactly what the isoelectric point is at each point of the process, but we do know which way it moves. And typically we don't change the reactivity of the reagent, but we can choose the reagent to match the conditions of the solvent and the substrate. So, predicting. We can predict what happens in the overall process by treating every step as a modification of the system. So, at any point, the system is however the substrate is changing, depending on what's gone before and what is happening in that particular step. And the sequence of reagents changes the substrate. And of course, the medium is critical in terms of delivering that reagent. So we need to understand what the impact is of each reagent on the collagen itself, and how those reagents are interacting depending on what's happening in terms of the reactivity of the medium, and how you might change that to influence the way that the reagents react with both the collagen and each other. So using the principles of leather science, we can predict the outcome of change at any point where you make a change in the process, whether it's adding something, changing the float, changing the pH. Anytime there is something changes, you can predict what the outcome is going to be. Now, more than that, you can think about turning it on its head, because if you want to change the outcome, then you can predict what you need to do to make that change. Which leads on to what are the requirements if you want new properties and performance in the leather. And perhaps think about extreme performance. But it does depend on knowing all this. It sounds complex, but actually when you get down to it and start doing the analysis, it is logical and it's relatively simple. So every time something changes in your process, analyze what's happening, so that you understand the impact of introducing that change. Does it make any sense? What exactly do you expect to happen? What is actually happening? So we need to understand the technological effect of chemistry. This is the coming together of leather science and leather technology. So those commodities that have a loop that can be closed. Let's think about what is in the overall process that you could influence and could remove from the environmental impact of the process. Sulfur, clearly from sulfide and herring, but also sulfate. Sulfate is undesirable in the environment. Electrolyte, the worst problem that leather makers face. Chromium, actually, this is a relatively simple matter, certainly compared to electrolyte, because we know how to control chromium so that effectively the loop is closed. What about the protein? There's a lot of protein that goes out to waste that needs to be utilized in some way. And water, again, this is relatively simple because we just need to have creative recycling. So recycle, reuse, or upcycle, but don't dispose. What about at the end of life? What does leather science have to offer? Well, we can recover the leather, we can recycle it either intact or reconstituted. We can recover chromium, that's relatively straightforward as far as the principles are concerned. Almost certainly you need to denature chemically, often by high temperature and pH, but that's a simple matter. That will allow you to recover chromium, probably not recover intact protein, but doesn't matter about the protein, that can go back to the land, that's no problem. We can generate biogas. That's actually easier with chrome tan leather than it is with veg tan leather. So in this instance, chromium is more ecological than veg tanned. And you can introduce a redox element, a transition element into collagen, and this will have a slow reaction to degrade the collagen. So you can actually introduce into the leather the seeds of its own destruction. Okay, let's finally deal with leather scientists. If we're going to create leather scientists, then we need to rethink the science and technology balance. Around the world, the industry calls for more leather technologists because they're extremely useful in terms of maintaining production, problem solving, keeping the business going. But they might not be so good in terms of developing new lines for the tannery. So we need to rethink the science technology balance depending on what sort of product in terms of scientists or technologists you want to produce. And if we want to create leather scientists, perhaps we ought to be starting with a chemistry degree. Whilst there are plenty of technologists around, and certainly in the past, that have turned out to be really good scientists, in general, it's easier to turn a technologist into a scientist than to do it the other way around. And the important question here is, who teaches the teachers? Leather scientists are getting pretty thin on the ground. Then there's a danger of a downward spiral because you need those highly qualified people to create the new generation of leather scientists. In my view, that's the rate determining step in achieving sustainability. So it's over to you, CLRI. Finally, some acknowledgements. Thank you to Dr. Sriram and CLRI for the invitation to participate. Many thanks to Nishad. And regards and best wishes to all my Indian colleagues and friends, in particular to Dr. Raghava Rao. Happy retirement.
Thank you, sir. Thank you for an inspiring and enlightening lecture. You have really set the platform for leather sustainability with the leather science perspective. And we will take one or maximum two questions now. I request all to post your questions in the chat box. And at the end of the session, we will take those questions. So we have one question. Okay, so
can I just take the opportunity to wave to Sami?
Oh, Yes, please. So you have to unmute yourself. TR, sir.
It's not muted.
Hey, Tony, great to see you.
Good
Wonderful.
to see you, Sammy.
Very good to
You're
see
looking well.
you. I hope so. These are difficult times.
Yes. Yeah. Yes. Now, I haven't even seen the score in the test match.
Yeah, you guys won.
Did we?
England won by innings. Yeah, innings, and it was in leagues.
Right. One each. Yes.
That's right.
Very good.
Thank you.
Nice to
Thank
see
you.
you, Tony.
Tony, congratulations.
Good to see you.
Right.
Thank you.
You looks the same. Even so, after so many years.
Yeah.
So if we don't have questions now, we will take it up in the end of the session. We proceed. Thank you once again, Professor Covington.
My pleasure.
The next speaker we have is a close friend and an alumnus of CLRI, Mr. Atto Ondu Legacy. He is a national project coordinator in UNIDO from Ethiopia. He had been the Director General for the Ethiopian Leather Industry Development Institute for 9 years from 2009 to 2018. He had been a member of National Export Council Steering Committee, National Standards Council of Ethiopia, and is in the board of management of several companies as well. He coordinated with many governmental agencies in coming out with policy support for the growth of leather sector in Ethiopia. He is now going to talk on sustainability and circular economy in leather processing with Ethiopia as an example. Over to you, sir.
Thank you very much for your invitation, Dr. Nishat. And also I want to say hi, all of you here, distinguished speakers. And also I'm very happy to see Dr. Tira Masami and also Dr. S.H. Rajamani, my longtime friends. And also I want to say a great congratulations for Dr. Raghava Rao for your retirement time. I wish you a good retirement time, and I will go to my presentation here. As it is mentioned, now is it clear and hearable? Yes.
Yeah. Yes, sir. It is clear. You can go into the screen, full screen mode.
Okay.
Slideshow. There is a slideshow, the top icon. Home, insert, design, transitions, animations, then you have the slideshow. After that, yeah. No, not insert, sir. Design.
Design.
Transitions, animations, then you have the slideshow.
I didn't get it.
The sixth one, sir. The sixth one from the file. The sixth one is slideshow. Yes, sir.
Here is it.
Sir, sir, you can put F5. Press
Function
F5.
F5. Function F5. In your keyboard, you will find function F5. Or we can proceed as such also, it's not an issue.
I can't manage it, so I will continue like this if it is.
Yeah, no problem, no problem. It is visible, the slides are visible.
Okay. Now my topic is on sustainability and circular economy in leather processing. Just I'm not taking so deep scientifically like Professor Covington, but I'm talking about the management view of sustainability and circular economy. I start with sustainability, and according to the World Environment Commission definition for these developments that meet the needs of the present without compromising the ability of future generation to meet their own needs is defined as or known to as sustainability. That is the definition for sustainability. And sustainability, the dimensions, there are 4 dimensions, which is also proposed by these environmental commissions. These are social dimension for sustainability, economic, political, and environmental dimensions. Now, all stakeholders, including government, research centers, and academic institutes, and also private sector owners who are contributing for sustainable development, has to consider all these, or they have to sum up their activities, because sometimes we are looking only for research and get results, but ignoring other things, it is very difficult. With the private owners, according to my look, and they see from the private owner side, most of them, they will see the economic aspect and the feasibility to take new technologies. And from the government side, negligence and delay to take action and to support the research on sustainability. And from the researchers' perspective, even though they are trying to focus on their scientific research on environmental issues and its economic importance, they ignore the social and also political importance of their research, which is very sensitive to the government to support it financially. So the research has to be supported from all sides, either from private or from the government side. To meet their interest is very, very critical. So when we look this, the government attention of in sustainability in Ethiopia, for example, it was planned to have Mojo Laser City as a form of industrial park for 30 tanneries in 2011. But till now, it is not implemented. This is, even though the project is very important to play a great role for the sustainability of the laser sector, now they are affected by closure for not meeting the environmental standards. And now, from previously we had about 35 tanneries, now they are just decreasing down to only 18 tanneries. This is an example of poor appetite from all parties, because the initiation of the project is from academic institutes, not from the political parties. If the request is from there, it will be finalized till now, because the government is not pushed, and we are not going to show to the government the political and the social affair of the project, but we are going to talk only the side of the environment. When we come to the circular economy, and what does it mean? Why circular economy? What is global trends will take to this point is my next point. If you see now the world population, and it is subjected to or estimated up to 2030, and the world population is increasing, and the world middle class, it's at the dark color, is now also growing, but the population in the middle class is somehow a big difference is there. When we see the world population and resource use, you can see the billion tons, and the world population in red color is there, and the world middle class, as we see from the last slide, it is there, and also the blue color, the global resource use now is exceeding and developing in high term. This is will go further for all industries, how to just get a solution or for our natural resource. If you go for urbanization, now you can easily understand what does it mean by urbanization, and the contribution of urbanization for the environment is very much high when you compare with the rural one. So when you see the urbanization is increasing alarmingly, and when we see world energy consumption, and you can see now it's still the major energy is coming from oil, and the most environmental friendly energy source in hydroelectric is very, very few, and the others are from coal. These all have a great impact on the sustainability and also for the environment. If you see for global water withdrawal, and because leather by itself is using a lot of water, the blue color from here is used for agriculture, because you can see the number of population of the world is continuously increasing, and this all is need food, and also the agriculture has to grow by itself, and you can see how much water is extracted, and this is continuously increasing, and the industries are growing. When we compare with the 20th century, and now we are in 20th century, they are increasing because the population is also increasing. When you see global trends in cereal and meat production also very highly increased, global total use of nitrogen and phosphorus fertilizers is also increasing. Increased use of irrigation is also very much increasing here. And also the global pesticide production is very much increasing. And all these are affecting our environment. If you see for world cereal production, because of agriculture and also fertilizers and other agricultural products, cereal production is also increasing, because we have to feed all the population, and all this has its effect. If you see, the fertilizers are also now increasing the production of fertilizers, and this all has an impact on the environment. And global chemical production is global change, and synthetic chemical production is also increasing. So by looking all this, world plastic production, as you see, is also increasing, and global lithium production is increasing, and global cement production, as you see, is highly increasing. And finally, our environment and our world becomes like this. Now we are at the problem of this, and all the industry sectors, including the laser technology side or the laser processing side, we have to improve our universe. Otherwise, we may be after sometimes the distractors of our world or our planet. And the urban development like this, we are looking without any green plants here. You can see how the urban is developed in the world, and this leads a great environment problem, and which is now the sustainability and circular economy is a great agenda for the future to solve all the problems what I mentioned here. And pollution, as you see, kills people and damages economy, and this is a problem according to our estimation. This is a report from the UNIDO side, and 9 million premature deaths per year is 60% of all deaths in the world is due to pollution, and $4.3 trillion welfare loss per year. 6% of global economic output is also due to pollution. This has its own source, and you can get from the slide. So is not our world is too small for so much waste, for so much materials, water, and energy use. So we need to have a solution. In today's economy, 65 billion tons of raw materials per year, that is 22 kg per person per day, are extracted, harvested, and used. Only 7% of these materials are reused and recycled. So we have a lot of gaps to fill.
நோவாவின் மீது அவருடைய அருள் பார்வை விழுகிறது. இந்த நோவாவின் குடும்பத்தில் இருந்து நான்
Request everyone to please mute their mic.
இந்தியத்திலிருந்து நாம் பல முறை வாக்களிக்கிறோம்.
Agnes,
மட்டுமல்ல, ஆபிரகாமை தேர்ந்தெடுக்கின்ற பொழுது
Agnes, could you please mute yourself?
Shall I continue now?
Yes, please.
Okay. As I mentioned, for raw materials, 65 billion tons of raw materials per year are extracted, harvested, and used. From this, 7% of this material.
Sir, your screen is not, Atowundu sir, your screen is not shared.
Not sure.
It is coming. It is coming. It is there.
It is visible. It is visible.
Yeah, screen is visible, very much visible.
Okay, sir, thank you.
Okay. And
Please
about
proceed.
8 billion tons of plastics enter the oceans every year. 300 tons of gold is buried in 50 million tons of electronic waste every year. 40% of greenhouse gas emissions are attributable to materials management. And what is now circular economy means? It is already during the discussion of professor, and some of the points are already touched. Now, this is the reduce environment footprint and also to generate increased income, reduce resource dependency, and also minimize waste. This is a circular economy definition. We are going to work for cleaner production using fewer resources and also better service to extend lifespan, collect as end of life, separate ways to reuse resources, and also green products, toxin-free, long-free, recyclable. And these are the idea or the concept for the circular economy. Now, systems thinking about products, product parts and components and materials, innovation, stewardship, and collaboration have the potential to launch new business practices and models that extend lifetime of products, parts, and components so that embodied materials. This already mentioned during the last presentation by the professor, and waste is a resource that should not be wasted, reused, repaired, remanufactured, and recycled products. Parts and components create new opportunities for business and jobs, paying for performance, access to products rather than ownership can enable both producers and customers to capture and share value. So this is about it. And in manufacturing, use of this RACP solutions, that is better process control, equipment modification, technology change, on-site reuse and recycling, production of useful products, product modification, good housekeeping, input change, and these are resource efficient cleaner production. All are the part of the circular economy which we are going to consider. And where can manufacturers do more and better with less is this one. Eco-industrial parks are one of the good ideas to implement such kind of things. Individual RACP solution is resource efficient cleaner production, material efficiency, water efficiency, and energy efficiency. In this regard, especially CLRI has a lot of research works on material efficiency, water efficiency, and energy efficiency, especially Dr. Raghava Rao and his team. And industrial park level also we can collect collective resource efficient cleaner production, that is common infrastructure, resource supply, water, energy, material, we can save it. Environmental and social services also can go with this one. So I want to, before I am going to conclude my presentation, I want to talk about the colleague and also instructor and who guided me to the laser technology when I was in CLRI, is Dr. J. Raghava Rao and his contribution for sustainability and also in circular economy, I want to give you some points. Now, here is Dr. Raghava Rao. He was in Ethiopia for many times, both for benchmarking and also for twinning program with us, and to share all his experiences. Dr. J. Raghava Rao is a revolutionary for the laser sector, and according to me, and he has demonstrated these fundamental changes through paradigm shift from chemical to bioprocessing, narrow pH laser processing, pickle-free chrome tanning, reverse laser processing, and integration of processes, thereby avoiding the do-undo process logics. His research has generally pertained to the study of zero waste tanning methods, particularly chrome management in tanneries, through various approaches, and the application of his fundamental knowledge in the chemistry of chromium has led to the development of an innovative high exhaust chrome tanning result, as well as formaldehyde-free chrome syntan. And the work on biocatalytic laser processing is path-breaking work in laser science with a paradigm shift from chemical to bioprocess, the recovery of value-added biometrics from tannery wastewaters through aqueous two-phase system has been standardized. The researcher has been involved in the development of salts from fleshing waste from laser processing. These all are the contribution of Dr. Rao for sustainability and also circular economy. Here are my concluding points. We have only one common planet for the time being, because I caught it the time being. Some of the people think to live in another planet maybe after some time, but for me, we have only one common planet for all of us, is because we are gathered here on behalf of Dr. Rao and from different parts of the world, but we have the same plan. So keeping the environment and working sustainability and circular economy has to be a common agenda for all of us. We have a responsibility for future generation. We are not going to destroy their future and resource. So let us stand together for sustainability and circular economy by sharing all resources of knowledge and finance, like what Dr. Rao did for all parts of the world. And I thank you very much for giving this time. Thank you.
Thank you, Towondu. That was a very inspiring talk, and thank you for presenting the leather sustainability with Ethiopia as a case study, and also for highlighting Dr. Rao's contributions towards leather sustainability. Thank you, sir. Can we take one question on this subject now? Else, you can post your questions in the chat box. We'll have it at the end of the session. Okay, so we move on to the next speaker. So we have another eminent speaker, Dr. Wolfram Scholz, who is the director of engineering company W2O Environment and has supported the leather industry for 22 years, developing efficient effluent treatment and recycling systems. As an expert in environmental technologies, he has provided workshops for several international organizations and created an interactive e-learning course in cooperation with UNIDO. Dr. Scholz is now the chairman of the IUE Environmental Commission of IUL-TCS, fellow member of SLTCS, and guest professor of the Department of Biomass and Leather Engineering at the University of Sichuan, China. He has been commissioned by several major companies worldwide as an environmental consultant, and his expertise in current R&D activities, technological developments, and environmental legislations affecting the leather industry is sought worldwide, thus supporting the leather industry on environment standards and regulations. And he is going to talk on environmental sustainability developments of the leather industry. Over to you, sir.
Yeah, thank you very much, Professor Nishat, for your kind introduction. Start to share the screen. Good. Good afternoon, everybody. I would like to welcome you to the environmental sustainability developments of the leather industry, to my presentation. First of all, I would like to give you a short introduction about our work of the Environmental Commission of the IULTCS. The IUE Commission has representatives from about 30 countries worldwide and meets up regularly once per year to interact on environmental issues and measures and to reduce the environmental impact of tanneries worldwide. The IUE Commission has developed environmental guidelines and environmental protection for the leather industry based on field developments and expertises in different countries, and has produced 12 IU documents which can be visited, which you could visit on the webpage of the IULTCS. These IUE documents are very helpful for the leather industry worldwide. And the most recent one, the IUE 12, is about the minimum environmental guidelines, which is a good starting point for tanners also to implement sustainable measures by conducting a self-assessment. The document gives recommendations regarding water usage, very important, monitoring, as well as for all important parameters such as water usage, COD, monitoring of different parameters, important parameters like chrome, COD, nitrogen sulfides for tanneries, which are operating their own effluent treatment plant or which are discharging to a common effluent treatment plant. Besides that, the IUE gives also recommendations on on different environmental parameters and gives an overview of technologies to achieve these standards. We have added a new open training source on the IUE web page, which you could visit, which are the tannery effluent videos, which show key technologies for effluent treatment. And currently, together with CLRI, we are working on a new document on best available technologies, which is currently on the review stage and which will be soon published and available for everybody worldwide as an open source. But now I would like to come to my presentation. So the leather industry is improving their sustainability, especially by reducing freshwater consumption. This can be done, for example, by collecting rainwater or by recycling water using membrane technology, by reducing the energy consumption and using photovoltaic cells or solar power heaters, renewable sources, then also to converting waste to energy with waste to energy plants, or by installing energy efficient equipment for wastewater treatment, energy efficient pumps and blowers which consume less energy. And then last but not least, what is very important too is the reduction of solid waste disposal, because here that's a very important factor for sustainability, to reduce the generation of waste. And this can be done by optimizing process chemical uptake or by byproduct utilization. I would like to give some examples. Of course, I cannot show everything because there's not too much time during this presentation. But I would like to show you here a rainwater collection system which was installed in China. This system can collect rainwater up to 50 cubic meters of rainwater from the roofs a day. The rainwater is collected from the roofs, is filtered through a sand filter and then pumped over and transferred to the freshwater tank. This rainwater collection is very easy to install and it had a very short payback time for only a few months. And a little bit too fast, I have to go back. So yes, a very good example for sustainable biological treatment is membrane bioreactor treatment. Membrane bioreactors is a combination of activated sludge system with membrane filtration, which retains all the microorganisms. In this way, we can retain also slow-growing microorganisms, and which are very effective to also degrade hard COD and difficult degradable substances. Because with a very high concentration of microorganisms, we can reduce the biological plant size by about 2/3, and we can reduce the energy variation by about 50%, which is a great saving. Another advantage of membrane bioreactors is that the sludge can be, the surplus sludge generation can be reduced. Conventional plants produce 30 to 50% of sludge of all BUD degraded. In the membrane bioreactors, we can reduce that to 5%. And further, membrane bioreactors show a much higher efficiency in COD degradation, up to 95% compared to 88% of conventional plants on average. And achieve also full nitrification. So we can reduce ammonia to less than 2 milligrams per liter, and of course, nitrate and total nitrogen also to a much lower amount. But why are they so effective in biodegradation of recalcitrant CODs? The membranes retain organic substances, and the retention time inside the biological systems increase. And so even hard, difficult degradable substances can be completely degraded. Beside the membrane bioreactors are also modular systems and are easy to enlarge. We would like to show you a membrane bioreactor with submerged membranes installed in China in 2011, which is continuously in operation and has a capacity of 50 to 60 cubic meters per hour. So a very efficient system. And the result, a very clear permeate, which a very clear permeate which has less than 5 milligrams per liter suspended solids in BUD, and which is ideal for the following treatment in reverse osmosis or nanofiltration plants for water recycling. Another very good treatment, alternative treatment to biological treatment is our reed beds. I would like to show you here example in an exotic tannery of the Hermes Group in France, which has installed a reed bed plant. Reeds are aquatic plants like Typha, Phragmites, or Vetiver, which are planted in hydroponic culture and which treat the effluents due to various effects. So some nutrients are assimilated by the plant. The plant transfers oxygen actively from the leaves down to the root zone where bacteria degrade organic substances, and we have some absorption on the stone and gravel. And here in this reed bed plant, we have 7 beds in series with about 450 square meters, treating 165 cubic meters per day. The plants, the reeds achieve a COD reduction from after primary treatment in the feed 800 to 1,300 milligrams per liter down to 200 or 350 milligrams per liter. But what is a sustainable development tool is to recycle after the reed bed the water. And this tannery is installed a nanofiltration plant to actually enable water recycling, which is running on about 6-7 cubic meters per hour and can recover up to 77% of the overall effluent, producing a high quality, slightly salted processed water, which can be recycled back for later processing. Here we have chosen nanofiltration membranes because this reduces the concentration effect. Nanofiltration retains bivalent ions and only leaves sodium chloride permeating. So we don't have concentration effects like with our O plants. And nanofiltrations also have the advantage that they consume less energy as they run on lower pressure of only 8 bars compared to reverse osmosis systems, which run on 40, 50, 60 bars. Nevertheless, we have to use anti-scalant to reduce the membrane scaling, and like all membrane systems, they have to be cleaned regularly, possibly every month or 2 months. There is a cleaning important for the nanofiltration membranes. You can see a photo of the plant comprising of 14 nanofiltration membrane modules. And the result is what we achieved. Reed beds in combination with nanofiltration showed a very good and stable result, and achieved in France the strict discharge river norm to river of 125 milligrams per liter of COD. On the left side, you can see the permeate, which is perfect for recycling. It has always less than 1 millisiemens of conductivity. And on the right side, you could see that we discharged some of the permeate in combination of the reed bed effluent to always meet the discharge limit of 125 milligrams per liter COD. Solar power heaters are also a very good form, a very good example of sustainable development. Here I would like to show you a solar plant installation in Vietnam. Prime Asia made this installation, and they use solar power heaters, which are glass tubes which contain a liquid which heats up with the sunlight and is afterwards pumped and transferred to a heat exchanger, which heats up the process water, or the water which are used in the tannery, and which also can be used as a preheating for a biomass boiler. So in this case, this very good example in Vietnam showed 100% renewable hot water production for leather and for sludge drying. Solid waste management is very, very important for tanneries. And here there's a lot of room to actually achieve sustainable advantages. Tanneries are facing rising solid waste disposal costs because of two things, two facts. The availability of landfill is diminishing, and recent environmental legislation like the Landfill Directive, which aims to prevent or reduce the negative effects on the environment from landfill, comes into force. Besides that, the costs for transport and safe disposal vary depending on local legislation, but they are between 150 and 250 euros per ton, taking into consideration that a tannery, a medium-sized tannery, can produce 10 to 20 tons of sludge per day. So there's obviously a return on investment for all measures which are addressing solid waste reduction. So how can this be done? How can we achieve a return on investment for sustainable measures reducing solid waste? Worldwide, chemical suppliers are working in optimizing the chemicals so to achieve a higher uptake in leather, because if more chemicals are uptaken in the leather, we have reduced purchase costs and treatment costs, and we can reduce the solid waste, and the tanner can reduce solid waste disposal costs. Another possibility is the recovery of byproducts. Many tanneries have installed already successfully chrome recovery plants, or are using composting their beam house waste, or recovering tallow from the fleshings, or producing gelatin. Another option would be to convert hair to keratinofertilizer. And last but not least, waste also gives the chance to produce energy in the waste-to-energy plants where biogas is produced, or in gasification plants. And I would like to show you some examples here about composting, which is a very common method to reduce organic waste, especially from beam house, for example, the hair, etc. And The composting is aerobic degradation of organic compounds. Bacteria, fungi, microorganisms degrade organic compounds. It's a thermic reaction up to 70 degrees. And what we achieve here is humus, new biomass, and also reduction of volume in prime materials, which is great because it reduces the volume which has to be handled. And last not least, humus, which is a valuable conditioner for soils, together with all the nutrients which are available in the humus. Tallow recovery is another example. We have here an example from the UK, in Humboldt, where fleshings, which contain about 10 to up to 15% animal grease and proteins, and water, 65–75%, are processed with steam hydrolysis to produce tallow. And tallow can be afterwards converted to soap, lubricants, or biodiesel. It's very interesting to produce tallow for a tannery because they can achieve a very high recovery rate of more than 90%, and they reduce the waste to landfill. However, all the water which is being separated from the tallow, which can be 60–70%, has to be treated in the wastewater treatment plant. Here I would like to show you a flow diagram of industrial type rendering. So the fleshings, lime fleshings, are collected, grinded up. Then afterwards the pH is adjusted, they're cooked with steam, and then separated in a three-phase decanter where fats, solids, and effluent water is separated. The water is transferred to the effluent treatment plant, and the product is tallow, which has a total grease content of 99.5% with less than 0.5% of water. Here I would like to give you a very nice example from a tannery in Colombia, Curtidos de Americana, which actually managed to reduce the solid wastes of trimmings by curing the trimmings with lime, deliming the trimmings with water, and cooking the trimmings to extract gelatin hydrolysate. In the following day, gelatin hydrolysate, which has about 8% gelatin concentration, can be concentrated up to 20% with ultrafiltration membranes to actually obtain a higher grade gelatin, which is afterwards left to cool down. It's cut in slices, dried in a drying tunnel, milled, and sold as industrial grade gelatin. Good. Here I would like to show you the photos. As you can see here, the trimmings, from here we have bovine trimmings, which are cured with lime, then delimed, then there's the thermal hydrolysis of lime trimmings to produce the gelatin hydrolysate, and a small membrane filtration plant on the left side, the bottom to concentrate the gelatin, and the cutting and drying of gelatin, which is in the following milled and used for to protect matches. Now I would like to come to the last two major waste to energy plants. It is possible to produce biogas, and biogas in an anaerobic treatment is an anaerobic digestion to degrade organic compounds without oxygen. Biogas contains methane and CO2, and anaerobic treatment is ideal to treat this highly concentrated waste we have from tanneries. It's a closed system, so there are less smells, and biogas plants produce a stabilized sludge, which is good as to be used as a fertilizer for agriculture, and last not least also to produce energy when the biogas is combusted. Would like to show you here an example of a big biogas plant in Germany. The plant is designed for tannery effluent treatment sludge, hair flashings and trimmings, and has electrical output of 1,400 kilowatts and a heat output of 1,200 kilowatts. And this an anaerobic plant provides for 98% of the energy and heat requirements of the tannery Südleder in Rehau in the south of Germany. So the tannery doesn't need too much energy from outside and uses all the waste to produce their own energy. You could see a flow sheet showing a substrate buffer, the anaerobic reactors, the biogas buffer, and the biogas purification system to clean up the gas. And a photo of the biogas plant, which is in operation already since several years. The biogas can be burned in a CHP cogeneration heat power plant, and here the energy is produced, electricity, and also the heat for the tannery processes. So last but not least, I would like to give you an example from the UK, the gasification plant at the Scottish Tannery Group, pyrolyzing waste to energy. Gasification is a different process. It's the only destructive thermal process to produce a combustible syngas containing hydrogen and methane. It's not like incineration system where all substances are burned, and gasification produces a syngas which can be combusted in the following and used to produce heat or power. So what are the main drivers to implement gasification? Of course, again, to minimize the waste disposal, to avoid landfill, then to recover chrome. It's possible to recover the chrome, to recover energy, and to reduce the overall power consumption of the tannery. Here I would like to show you a flow diagram of a downstream process, gasifier. As you can see here, there's the pre-dried fuel briquettes are added from the top, and they slowly sink down to the bottom, which goes along with the increase in temperature and under a limitation of oxygen. And we achieve a syngas which can be collected and burned to produce heat. The benefits for the industry is that gasification closes the loop and on the flow of resources through a tannery, because we recover energy and chrome and make so the whole production much more sustainable. It's a promotion of positive publicity by demonstrating environmental responsibility for a tannery which runs gasification plants. And last not least, because so much energy can be saved, we achieve a short payback of 3 to 5 years and a significant reduction of production costs. Practically, what can be produced is then a carbon-free leather. Why? Because leather waste contains 20 megajoule per kilogram energy, which is more half the value of coal. And approximately 85% of all the energy which is consumed in a tannery comes by thermal processes to heat up water or the space and for drying. So the remaining 50% are energy, which is utilized through energy consumption. And if the energy from the syngas, if the syngas is combusted, and if the energy is used directly, it's of course a big advantage because we have the best energy transfer like that, instead of running it through a gas engine. So with that, I would like to come to the conclusions. Worldwide, the leather industry is improving their sustainability, and the leather industry improves the efficiency of leather processing and the uptake of chemicals. Everywhere in the world, the leather industry aims to reduce the water usage and to implement recycling wherever possible. The companies improve the energy efficiency of effluent treatments by installing energy efficient pumps and blowers, and of solid waste handling, as we saw in the examples before. Implement renewable energy is also a typical fact for the world industry to become more sustainable and to reduce and utilize waste increasingly in a productive manner. These, regarding the examples I gave before, the waste to energy plants, the byproduct utilization, are now sustainable measures which are increasingly implemented in tanneries worldwide, which have also the positive effect of achieving a return on investment and to reduce the overall operation costs and energy costs of the tannery, beside sustainable effects. However, the tanneries also worldwide have to modernize the treatments because norms get stricter to achieve the full local and LWG and CDHC compliance of tanneries which are international norms. So with that, I would like to thank you for your attention. And I would like to thank you also very much for the invitation to participate. And I wish Dr. Raghuvar Rao all the best for his retirement. Thank you very much.
Thank you. Thank you, Dr. Wolfram. It was a very informative talk on various environmental treatment aspects, both for the liquid as well as the solid waste, which are being carried out to achieve sustainability. Thank you once again. The next eminent speaker we have with us is... yes, sir. You would like to say something?
Just well done, Dr. Wolfram, and it's an excellent presentation. Only compliments, and happy to see you on this occasion. That's all.
Thank you very much, Dr. Rajamani.
Thank you. So the next speaker is Mr. Kim Sena, who is Sustainability Manager at JBS Sao Paulo, Brazil. He is acting on the development of sustainable strategies like scientific-based approach on process optimization, aiming the reduction of environmental impacts, development of communication strategies, media engagement, environmental assessment of leather, which is life cycle assessment, conceptualization of social project, the third sector, upstream projects on animal welfare and sustainable cattle raising. So he is going to talk on a life cycle approach to leather production. Over to you, sir.
Thank you, Professor Nishad. I'll share my screen here. While I do that, I'd like, first of all, to thank for the invitation, but also for the opportunity to watch such informative lectures. I mean, the three of them, and I'll try to explore connections with what the other speakers talked about here, which is all, of course, interconnected. Share screen here. I suppose you're able to see by now?
Yes.
Okay. So, and this was one point, well, starting with Dr. Covington, he mentioned as one of the priorities how to deal and closed loops and how to deal with solid waste. But this topic was present in all lectures, and this is not a leather specific problem. It's of course a problem of industrialization of the world and higher consumption, as Mr. Leges was mentioning, how this is growing exponentially in the world. And this is of course a problem humanity has to deal with. The amount of waste generated is very high per person, but the problem is it's actually rising, and humanity so far doesn't have the solutions for all waste in terms of closing the loop. And we sometimes tend to overlook leather's role in this. I mean, of course, plastic is is the focus, and it should be, of course, because of the relative amount it generates in the world. But we in our industry do generate a lot of waste. That's the reality, and this is for several reasons, being them the natural characteristic of leather and the defects it has, but also reasons related to how it is industrialized and product design, surely. And to address this topic, we of course, my point here is, when we look at waste, we are looking at something physical, right? That's being designated to a landfill, for instance, if it doesn't have a better solution at that moment. But the problem is you did produce that. So for that kilogram of waste you're designating somewhere, you did extract a material. In our case, a cow was raised. You use chemicals, you use energy, you use water along the process. You transported that good around the world in several cases for several industrialization steps, and to reach to the end consumer. So when we do look at how to reduce the overall impact and the overall waste generation along the value chain, we of course have to look at it from a life cycle perspective. That's the only way. And I do say that as a challenge from the private sector perspective, for instance, when we have to design strategies for the reduction of the environmental impact of our value chain as a company, we have to develop a strategy. We have to look at it from this standpoint. And this means it can't be done alone. From a single company, no matter what company it is, no matter if it produces crust or if it only finishes leather, or if it detains the whole value chain, or if it's cutting the leather for the end use. It doesn't matter. The point is everyone has to work together and interconnect value chains and their challenges in material utilization for the end goal, which is the reduction of the overall environmental impact. And to do so, the one and only, or at least the most recognized methodology, according to ISO 14040, is the life cycle assessment. So the life cycle assessment is not the perfect solution so far, but it's the best way the scientific community made it possible to be able to compare materials. So sometimes you have to decrease your overall precision of your assessments, but in order to be able to compare, so in order to be able to establish benefits or problems, or how one's material, for instance, in our case, can compare with another material, and all under the same methodology. So by being this the most established methodology, what we did was, and recently we did run an LCA in one of our articles, and that was our first time doing so, but that was really enlightening, because the point is, it did shed a light for us on what were the highest impacts in our value chain, where should we focus, what were the hotspots, and how could we tackle the problems for a continuous reduction of the environmental impact of the leather we produce. So we did run this LCA, and after this first experience, it helps us so much in designing our sustainability strategies that we are now running 32 others. So this year we just we received data for 10 others so far, and we are expecting the other 22, but we are already establishing a database in order to compare different articles, and what we do in one that is good, what we do in a different one that we should bring to this first article and what are the problems in each one of them that we should address. But the importance here, the important part of this life cycle perspective is also to understand what happens upstream and how that responsibility is attributed to leather. Because in the end, according to the product environmental footprint category rules for leather, the environmental impact of cattle raising is allocated to leather. So, and not only leather, but all other products and byproducts of the animal. That's done from a mass and economic allocation ratio, which means that according to the weight that a fresh hide represents of the overall weight of the animal and the economic value it has compared to the relative to the other products and byproduct, the CO2 equivalent or the global warming potential impact from cattle raising should be attributed in some ratio to leather, but also the other impact such as water use, human toxicity, being that cancer related or non-cancer related, and so on and so forth. So the understanding of how and what should be allocated is really important here, and not from an improvement standpoint, an industrialization standpoint, which from that perspective, the allocation of the impact of the cattle raising shouldn't really matter, but for the overall image leather has, or the overall impact that is attributed to leather in the end. And we'll explore a little bit later on how that's important for leather's future. This is something that we really are looking at right now, which is, and these are digitized images of leather before being cut in an automatic cutting machine. And in this case, we're talking about Brazilian hides, and the natural defects are marked in colors there, specifically for Brazilian hides in this case, which comparing to Indian hides, we are talking about zebu here. So, I mean, we can relate, of course, when we talk about the climate and the defects the hide in the end will have. And what, from our experience, we of course, we have the fiber structure of the bellies, which of course are different, but more than that, the concentration of defects in these areas, such as bellies and necks, they are very clear. So we can see that in the end, these parts tend to be less used. When that became clear to us, we then started an experiment, which now is a product of ours, and we name it Kind Leather. It's a brand, but I wouldn't like to look at it as, well, one brand or one specific company's perspective, but as an approach, which could be done by whoever approaches it this way, any company, any leather producer in the world. And I tend to believe this might become a tendency for the future and the industrialization of leather, specifically because of the environmental concerns and environmental accounting that's now taking shape in the world, and how customers and value chains tend to worry about it and want to quantify what is the impact of their value chain. This is important here because when we look at the right side, we are looking at the leather that has been trimmed before tanning, so just after liming, when this large trimmings can still be redirected to other value chains as raw materials. And this is really important because these parts, as we can see in this image on the left, it's not that they wouldn't be used, the bellies specifically, is that they would tend to generate more weight, and for two reasons. One is for the concentration of defects, and the other is for the shape, which doesn't allow a high yield because of how it's shaped. Moving on here, so this is a regular production process, right? So you have a few trimmings before after liming, so before tanning, which are natural because of the shape, because of, well, you have flashings and you have to deal with it for the continuation of the production process. But in the end, you have a leather, and those parts of the hides of the leather I was mentioning will tend to generate waste. In the end, when we did look at it, we did and we started thinking about our way to reduce that waste generation. We looked from a design standpoint. So how can we look at it at the beginning and minimize the waste generation along the process? What we do in the end is we cut the bellies and the neck area, and we destine that to other value chains. In our case, it's easier, I guess, because our company is a verticalized company, so we have other colleagues within the same company that will produce, that will use these materials for these other production processes. But what we do then is remove those parts and move along the process only the parts of the hide that, that tend to be used the most, which is the premium part. What it means in the end is a higher cutting yield, and it escalates all the way back to the beginning of the process in terms of the overall impact of leather in the end. Because as we talked, if you use a kilogram of fresh hide to produce leather, you have to allocate that impact to your end product, and that's of course done in a relative unit, so square feet or kilogram or square meter of leather. But if you'll be bringing that impact from cattle raising, for instance, to the end product, when you do that more efficiently, you use the overall surface of leather more efficiently, you will bring less of the overall impact of cattle raising to leather, to every kilogram or every square feet or every square meter of leather. This is an image that helps to illustrate how you are able to use more the leather in the end. In this case, this is an automotive leather being cut. So the life cycle assessment brings a lot of insights to us, such as which chemicals that we use impact the most. So we can, together with our technical department, we are able to focus our R&D efforts and resources to maybe replace a chemical or reduce the usage of a given chemical, and also work together with chemical suppliers to better understand how the chemicals are impacting, and the chemicals are a relevant part of the overall impact of, specifically about global warming potential, for instance, or resource depletion of fossil fuels. So we are now, for instance, working with them to within this life cycle perspective to minimize the overall impact that's coming into our production process. And that's the main product we get from this approach, as I mentioned in the beginning, because we're able then to do what if analysis and test, right? And whenever we look at a new leather making approach, we are less reliable on a subjective approach, right? So it's this chemical or this material that we use was produced in a which has a sustainable story behind, but in the end what matters is, does it really impact less in the environment? Does it really have less externalities when compared to the one we used before? And to do that, this life cycle approach is the best we've seen so far, and it's really helping us. And this is not the main aspect, but we can't overlook it, which is this life cycle approach also helps us to communicate. And And we, again, the main focus is to help us be better, but we can't overlook that leather is under some really high pressure from whoever is comparing the environmental impact of materials so far. And in this regard, there is, for instance, the Hague Index, which was created by the Sustainable Apparel Coalition, and has a lot of brands from the fashion industry behind them. And their common goal is very clear and very noble, which is to reduce the overall impact of the fashion industry. And what they do is they collect LCA data and they analyze it, and they provide this hub for comparison of the environmental impact of materials. So there you find, within the Hague Index platform, you find distributed along these 5 impact categories, which are totally independent from one another. So global warming potential, eutrophication, water scarcity, fossil fuel depletion, and chemistry impact. And they compare different materials, and they provide a final result for that material. What is done then from the brand's perspective is, if they have a goal to reduce the environmental impact of their value chain, which is, of course, what happens nowadays with every serious and big brand around the world, they will use this tool to calculate and to bring this quantifiable approach to what the impact of their value chain actually is. And they have goals related to that. They have KPIs related to that for the purchasing department, for instance, for their sustainability department, for instance. So they will use this information for the decision of materials. Designers will have goals related to the impact of the shoe they're designing or the jacket they're designing, and they might make material decision based on this. And this is why it's really important that leather is able to properly understand how the impact is attributed to it, but also on how to improve and how to continuously decrease it. So as I mentioned, the Hague Index provides results in 5 different and independent impact categories. And this is, again, I talked that this has our brand here, but this shouldn't be the way we look at it. The way we should look at it, and regardless of brand and how we and whoever is producing it, the image of leather should be reestablished. As you can see here in brown in the bottom is how leather used to be seen before. Well, in our case, someone from the private sector studied further on and provided more updated and results from a value chain that was designed to be as efficient as it could be in terms of environmental impact. And the brown column, the brown bars on the bottom, is how leather was seen. So the designers faced the reality, or at least the information, that leather was a high impact material. The higher, the worst in this case. So 34 was a very bad number. And when we look at on the top here, so PU, synthetic fabric, and in this case it's a leather imitation, it had a 7.8 global warming potential score, which meant designers saw alternative materials, synthetic alternative materials as more sustainable than leather. And this is making them shift away from leather. And this is the importance of communicating and submitting the studies we do within any company of the leather sector to paint a more correct picture of leather, of a material that communicates a lot with the circular economy, which is produced from a byproduct of the animal protein industry, and if produced efficiently, if produced according to the high standards of the sustainability production and an eco-industrialization of a material, it should be seen as a material of low environmental impact. We are really glad we were able to move leather up a bit in this rank, as we can call it, but we are sure other colleagues from the industry, ourselves, won't rest before we are able to paint a better picture or a more accurate picture of leather for the world. And this is it. I'd like to conclude in saying again that I'm really glad to be here and to have experienced these other lectures, which were so rich. I'd like to congratulate Dr. Howell for his contribution to the leather industry along all these years, and very well-deserved retirement. I hope you really enjoy it, Dr. Rao. You deserve it. And thanks again.
Thank you so very much, Mr. Kim Sena. In fact, you gave a very wholesome picture of the entire life cycle approach, especially to have continuous improvement in the life cycle management. Thank you very much. We have a few questions posed by our virtual participants. This is from Mr. Das Gupta to Professor Covington. Compared to the global scene, where does the Indian tanning process stand vis-a-vis sustainability? How far are we from sustainability? Professor Covington?
Well, I have to say it's a while since I spent time in India, but I do know that there's been a continuing impact from the work at CLRI, and you mentioned the waterless tannage. I think there is a picture of continuous improvement in India, perhaps a little faster than in many countries of the world.
Thank you, sir. And this is again to Professor Covington from Ms. Hemalata. I'm quite curious to know about what happens to leather at the end of life, how it's really been disposed of after use.
Well, the truth is it just goes to landfill. The challenge is to do something with it. I mean, it's a serious pollution problem. It's an environmental impact. It's designed to withstand biochemical attacks, so it is going to sit in the land for probably hundreds of years. We haven't had enough experience with chrome leather, but I suspect it'll last for many years. So we have to do something about it. The problem, the fundamental problem in dealing with it, for example, with shoes, is that there's some leather in there, but there's an awful lot of other stuff. And separating the other stuff from the leather is a major problem. Some years ago, I did have a meeting with some French technologists who claimed that they had a system for separating the shoe leather from the other shoe components. But that meeting was the last I heard about it. But there's a lot of work that is to be done in order to save that leather from landfill. It's really too valuable to throw away.
Thank you, Professor Covington. This next question is from Dr. Saravanan to Attovondu. In order to ensure the sustainability of the complete supply chain comprehensively, what, in your opinion, will be the future? Is it either sustainability of leather making or sustainability of making wide range of materials and substances from animal hide? To Attovondu. You may have to unmute yourself, sir.
Yeah, just I can't hear you properly, so would you like to repeat?
Yes. In order to ensure the sustainability of the complete supply chain comprehensively, what, in your opinion, will be the future? Whether it will be sustainability of leather making or sustainability of making wide range of materials and substances from the animal hide.
Okay, from my perspective, I'm not just to stand on the sustainability of laser making only. So we have to look also other wide production or use of laser. That means in terms of pharmaceuticals and also in some time in the form of food also, but only laser, maybe we are now going to challenge by other industries also is already we are facing. So we have to see other alternatives. As in short, this is my opinion.
Thank you, Professor Ondu. Now this question is from Ms. Abhishri to Dr. Wolfram. If each country required different techniques and technologies to achieve the sustainability, how is the progress in sustainability established, compared, and measured in the global level? Dr. Wolfram?
Yeah. Good. I think it would be very important, and the tendency goes in this way with international norms and standards, to have a common standard for everybody. And we are going this direction now. That was first pioneer was the Leather Working Group, which created a standard, which is not a local standard, it's an international standard, and it's applied worldwide by about at least 20% of the tanners worldwide. What's coming now new is this ZDHC standard, which again will be a standard which will be in the future important for all tanneries to achieve. And therefore, I think it's important to have the same standards and the same norms of leather production worldwide and of environmental impacts, so that the real costs of producing leather are similar in each country. Because the main cost is sludge disposal and are the environmental treatments. And we require a similar quality of all the tanneries which take part in these international standards, so that they can sell sustainable leather in the future.
Thank you, Dr. Wolfram. The next question, or actually a suggestion from Dr. Chandrasekharan, in fact, to all the speakers, specifically to Mr. Kim Sena. The supply chain of leather and products manufactured in one place and distributed globally itself affects carbon neutrality, even if all green options are considered during production. So this has to be looked into by researchers. And another point which he says is recycling of used products, which again are manufactured in one place and distributed globally, poses challenge for recycling technologies. As an example, the use of recovered salt for productive purpose has already hit the roadblock in terms of economic viability. So your inputs on that, Mr. Sena.
The first point is a very interesting one, and it's a challenge we surely face. The leather supply chain is very spread out, we can say, which means a single product has to navigate a lot to reach its end destination. Understanding how to do that efficiently and as concentrated as possible is something the industry should really look at in that. Salt and about the salt recovery, but mainly and more broadly, any recycling technique we use in leather production, such as chromium recycling, right, and liming recycling, and also how, as mentioned today, how you can produce tallow or other products from your waste streams and byproduct streams is crucial to the overall sustainability of leather, right? And as mentioned by Mr. Scholz, that's the way for us in the future to be able to proudly say that leather has been shaped to a ultimate sustainable material.
Yes, thank you, Mr. Kim Sena. Well, now we are come to the conclusion of this excellent webinar, which had very excellent, very informative talks. I would just request all the participants to kindly switch on your video for just a minute so that we will capture this in memory. I request all the participants to please switch on your videos. Just for a minute to capture this momentous occasion. Yeah, we are done. Thank you very much. As I said, I really am grateful to all the speakers, illustrious personalities, for delivering such excellent and enlightening talks on this very important and a very pertinent topic for the leather industry in honor of Dr. J. Raghav Rao. And I thank all the participants who have joined us virtually. My special thanks to my guru, Dr. Ramsamy, Dr. Chandrasekharan, Dr. Rajamani, Dr. Sadullah, Dr. B.U. Nair, and many from industry, Sri N.R. Jagannathan, Sri Prasanna, Sri Aravindan. And we have had a lot of international experts joining us today. Dr. Patricia Casey, Dr. John Castle, Dr. Arifin, Dr. Karman. In fact, we have had more than 125 participants. So I thank wholeheartedly each one of you. Thank you one and all. And I thank the organizers of this webinar and our special thanks to our director for his support and guidance. Thank you one and all. Thank you so much.
Thank you very much. Thank you, everybody.
Thank you.
Thank you, ma'am.